So everyone, thank you so much for coming to today's experimental research methods in applied linguistics. And this is our workshop number 6. And next week, we have workshop number 7 on Q methodology. I'm sure Victoria is going to be there, your research really. And so thank you so much, everyone, for coming. And I hope that you find this session useful. And before we begin our workshop, I'd like to acknowledge and pay respect to the land on which we meet and the traditional owners. And as we share our own knowledge, teaching, learning, and research practices, may we also pay respect to the knowledge embedded within the Aboriginal custodianship of country. And maybe just the warm up. And I have 3 questions for you. What is experimental research? What is it for, and why does it help improve knowledge? Okay, let's do this together first, and then we can discuss through. Okay, so what do you think? The first question: what is experimental research?
I think it's about cause and effects.
Okay, cause effect. Something causes something. Yeah. Okay. What else?
Maybe it involves an hypothesis.
Hypothesis testing. Okay. Maybe more like a prediction, right?
Yeah.
Cause effect, and then you want to see, can something cause something, or can something lead to something, right? Okay. What else? No? All right.
Am I going to be involving a lot of different variables, I think?
Okay. With the cause effect, right? We have the term dependent variables. Yeah. So independent variables are something that will be considered like a cause or causes, right? And dependent will be like the outcomes of the thing there. So yeah. So you have different types of variables, and we will talk more about that today. What is it for? What is this designed for? So you for example, you can learn about cause effect, looking at qualitative research, right? You can interview people and find out, what might be a cause of something. You can also do that, right? But why do we need to do an experiment? So what is it for? Anyone? No? Ling Ling? Can't hear you. Okay, Hiromi?
To test some specific aspects.
Some
Yeah. That you would like to, you have a hypothesis and then you want to test out something. So you actually sort of create that kind of environment to test a very focused aspects. In my case, that's a sort of a linguistics aspect.
Okay. But actually, yeah, that's a good point. But usually when we want to do an experiment, look, it's basically, we believe that something exists and we want to see if it is the case, right? And in order to do that, we want to make sure that our conclusion is accurate, and that therefore we need to control the environment. So often it's basically, when we talk about experiment, right, it originates from the scientific research, like those science, say, biology, chemistry, this and that, right? So basically they want to see the effect of something, right? So then they can make a prediction. For example, if they want to examine the effect of light on plant growth, they need to vary the amount of light, for example, and the period of time. So then they can make an observation, right? That, we can understand the effect of light. And there could be many things, apart from that, there could be a combination of light, water, temperature, and so on, right? So we want to make sure that we can understand cause effect, and then we get the best solution out of it, right? And often you see that we don't actually know the impact or the effect of something until we find evidence to say so, right? We can't just assume that something is gonna cause something. We really can't assume that. We want to gather some systematic data and evidence to ensure that, because otherwise, if we don't, it can be costly, right? And sometimes it can be dangerous. So imagine an example of that would be a vaccine. If they invent a vaccine for to inject on people's body, they need to make sure that it works and that it is safe, right? Before, and then they need to gather evidence and until it is really safe, and also it really can prevent a particular type of disease or whatever things that, and then by that, then they can inject on people, right? Because and at the same time, they want to make sure that they understand side effects and other things. Okay, so that's what it for. We want to make sure that we have robust evidence to prove our hypothesis that something works or not, right? And therefore, it can only the third question: why does it help improve knowledge? Anyone?
I think it's trying to establish a causality relationship.
Okay, that one lead to another, right? So make a sort of prediction. We can predict, apart from that cause effect, we can make a prediction by looking at the cause, and so on. Now, how would this work in, say, in language learning, in language use, or in applied linguistics? How would this work, Victoria?
It can help determine best practice.
Okay.
To really solidly show if one practice is more effective than another in a certain situation.
That's very true. I mean, this is actually part of the reason why we need to do an experiment, right? We could have different conditions, like, for example, nowadays a good topic is AI, right? We want to see if AI can help people learn the language effectively, and we can have various conditions there, like AI, maybe different program, and see which one's more effective, and maybe AI plus human partnership, and without and versus with human partnership, like with teachers and so on, right? And also we want to make sure that also study if AI has some negative effect on learning as well, and we know that is often the case. All right, that's good. Now I'm going to ask you to do this for me. As you know, I already gave you the file. Yes, it's going to be individual. So it's called pre-knowledge. So I'm going to give you just 10 minutes to do this on your own. And then try to put the answers there. So I have 5 questions. I want you to think about the problems there and then try to type answers, and in 10 minutes, then we'll discuss together. Does it make sense? The questions will be challenging, and I would say try to answer the best you can. Try not to use AI. Excellent.
Tough questions.
Those questions are very tough. I don't know. I don't know most of them.
Yeah.
Sometimes it's often useful to do a bit of self-assessment and learn from problems. I think problem solving and experience the problems and then learn from it, and rather than people telling you what it is, right? Okay, let's take a look at some of the answers together, right? So this is just to do that. I think the reason I asked you this is I can talk about some of the answers, which I would then lead, talk about in the subsequent sections. And I like to see how you are doing with this. And I'll try to answer some of the questions later that you may have. Okay. So what is the difference between a confounding variable and a mediator? Why does the distinction matter for causal inference? Anyone? What is a confounding variable? Vincent?
So, sorry.
Oh, go ahead, Victoria.
Victoria, if you want to go, you can go as well.
Thanks, sorry. So that's going to get in the way of your results, and you're not going to be able to make some clear judgments about what's going on.
Okay. Like interference, right? Interfering factor. Okay. All right. What about a mediator, Vincent?
I think a mediator is something that actually within the causal chain. So the confounding variable is actually outside of you trying to have the cause and effect analysis, but while the mediator is actually inside.
Okay, that's a good one. It's the link, right? It could be a link. For example, it could be the time, to mediate the learning or something. It could be the link there. Yeah. Okay. And why is it important to distinguish the two when we look at causal inference? Like in an experiment, right? We want to look at cause effect, right? And we have the main cause, which is like, say, a treatment or teaching intervention or use of something. We want to make sure that can lead to to the change of learning or performance. But why do we need to consider confounding and mediator in research like this? Anyone? Hiromi?
So the mediator, helps the variable to reach the result.
Mhm.
Therefore, it's part of the system.
Yeah.
While confounding variable may look like it's affecting the result, but it's actually shouldn't be considered and then maybe controlled.
Yeah, okay, that's a very good point. Thank you so much. You don't want it can be misleading. Confounding variables can lead to misleading outcome or conclusion. Okay, it interferes the outcome. Therefore, we can't really be sure that our treatment or the the cause of something actually can lead to a change. So basically, when we look at confounder, right? It's something that can influence both the independent and dependent variables, and therefore it can lead to spurious relation. I will tell you what it is in a moment with an example. A mediator, on the other hand, is used to explain the mechanism through which the independent variables affect. So mediator is to do with the independent variable or the treatments that you want to examine. Okay. So a treatment can be a teaching condition or activities, and so on, right? And therefore, it's really important for us to differentiate the two and identify as much as you can. There are so many out there, but the key reason is you want to control confounders. Okay, you want to control confounders. A very good example of confounders, right, would be something like language proficiency levels. It can be a confounder. Because if certain groups have higher proficiency and another group has say lower proficiency, and then you have some activity, and it looks like the treatment itself may be working as well, but the proficiency will play a role, and it can determine the different outcomes, right? You might conclude that this teaching method is effective because people gain higher score, right, at the end. But actually, it just happens that the experimental groups contain a lot of highly proficient learners, and that can also play an interaction role with the treatments. Yeah. Okay. So now it's really important for us to really consider this issue because, for example, if you found that learners with higher motivation score also in higher in English proficiency tests, right? So it looks like, oh, motivation can lead to higher L2 proficiency, right? So because of that, however, okay, it might be affected by a third variable that can influence motivation and proficiency. For example, you can have things like socioeconomic background. Rich kids who have more money from their parents to take extra class or to do many things, right? Including private tutorials and so on. And then maybe they have a lot of prior exposure to English than other people, right? And therefore you can see this as an example of confounding variable. So higher motivation to learn English and also higher English proficiency can be seen in this way. So therefore, if you think about it, it could be access to English-rich environment can lead to higher motivation. And at the same time, access to English-rich environment can lead to also higher L2 proficiency. So they are confounders to the experiment. Okay. And therefore, we need to really be careful with these things like, context and so on. Another example of something that we need to think of in terms of mediators, right? So something like this. You investigate corrective feedback. So this is in SLA research mostly. They look at correcting errors and so on. It's very linguistic, more or less, to see if they can improve L2 grammar accuracy, right? You want to see like if you tell people what's wrong in their sentence or in their speaking, can they improve the grammar, right? And in this case, you can see that there could be a lot of actually many mediators in there. But one thing that can be a factor and mediate this is noticing. If learners can notice the grammatical gaps, they are likely to then pay attention to the issues, right? So noticing here is a mediator. It's part of the corrective feedback as the independent variables that you're interested, right? So in this case, you can see that causal pathway would be something like you provide corrective feedback to learners, and learners must notice. If they don't notice, they can't improve their grammatical accuracy. So noticing itself here, you can see, is an example of mediator. In applied linguistics, there's so many things, especially in language learning. We have like strategy use, strategic competence as a mediator. We can also have other things as mediator as well, like for example, the time and will play a role in there. Numbers of hours will play a role in there. All right. Second question. I will come back to all of this in some way. In experiment, right? We'll talk about random assignment in a moment, but just assuming that you know what random assignment is, is often described as the gold standard, right? What exactly does random assignment achieve and what does it not guarantee? Anyone? Vincent or Victoria?
I think it might help reduce the possibility of bias or confounding variables in the creation of groups, but I don't think it can necessarily guarantee that because there will be other biases, other confounding.
Okay, of other things there. And okay, that's a good point there. I think because in reality, there are so many independent variables out there. We can't have a complete control, right? And if you control too much, the outcome might not be generalizable or useful in real life situations. Like when you control like time and environment completely, that's like experimental conditions, right? And in the reality, it's all messy. right? People do things and messy, people are lazy, some people are hardworking, and even that some teachers, right? So if you want to do an experiment with a teaching method or something, and then you say like this teaching method really helps learners improve their learning or whatever. But if you have a lazy teacher doing it, it's not gonna be successful, right? And or if you have um the hardworking teacher doing it, of course it's gonna be successful. So it's hard to argue on that. So in this way, we know that random assignment, and I think we need to talk about it later, random assignment versus random sampling. I think that's what we need to talk. Really, it's try to distribute a lot of the known and unknown characteristics of participants into different conditions. And in other words, you want to reduce that confounding variables, and also to reduce any bias there. Okay. An example of that, imagine like you do research, right? And when you recruit participants, I mean, people who are really motivated to do it, they would be say, I'm happy to do it, right? So their motivation, right, will play a role in there. So you only get a sample of the people who are really motivated to be in your research, and people who are not really motivated will not be there. So you miss out those people, and therefore your conclusion will only be based on this group of people, right? So it's really hard to generalize that. And therefore, when we work on random assignment, we want to ensure at least we can distribute people into different groups. So we don't have just one group with high motivation, and the others like with something else, and then it affects the outcomes. That we want to minimize that things there. And again, like you said, Victoria, it doesn't guarantee even that, especially when we have a small sample in our research, right? It could be many things there. For example, it could be it doesn't solve problems of poor manipulation. So you might set up a conditions poorly. You still have a lot of holes in your experiment, and then even if you do random assignment, it still doesn't help, right? Or even sometimes there could be attrition problems, right? People drop out. Yeah. Usually in experiment, we want to do statistical analysis, comparing before and after, or comparing groups, right? And if you can't have the number, you really can't perform statistical analysis. You can try those non-parametric tests, like you can't meet normal distribution, you can try that. But even that, if you have low numbers, like just a few there, then you really can't do it. And of course, there could be issue with a measurement error. You know what measurement error is? Measurement error, anyone? No? Okay, it's to do with the instruments, right? If you give English proficiency tests, it may not be reliable, right? So when it is not reliable, it's full of errors in there. Okay, because errors makes inaccurate judgment. Okay, we call that measurement errors. And measurement error is actually a complex issue because it's to do with the methods, right? So for example, you might choose multiple choice questions, you might choose true false questions, you might choose short answers like I just gave you. If I gave you multiple choice questions in this pre-knowledge about experiment, you might perform better. You might, really know I got all the answers correct, right? But because I have to ask you to write the problems here, and it's, oh my god, I'm performing poorly. So this is an example of measurement error. Okay, that can influence the outcome. And another issue is low ecological validity. So ecological is about the environment, right? The authenticity of it, the reality of the situation, and so on. The third question, what is the purpose of a manipulation check? So we want to check the manipulation, and why can relying on it too much can be a problem. Now, what is a manipulation? Before we say the purpose, what is a manipulation, as you know, understand now? Hiromi?
That's something I didn't understand. And then I was trying to find some examples. And so if we know what kind of examples, for manipulation, check, we will probably understand.
Okay. Vincent, do you know what manipulation is?
Is that something you're trying to like actively check whether your independent variables are actually being implemented to the participants? Something like that?
Okay.
Yeah.
Okay. So look, the word itself in reality is not preferred, right? We don't want to do manipulation like this and that with people because it's abuse, right? But in experimental research, we need to do that because we want to make sure that the condition that we interested actually is controlled. And then therefore, we can test the difference in the outcome later. So we need to do manipulation. So manipulation is to do with setting up your experiment to control certain things for your students. So manipulation could be something like the amount of time that you allow people to do the task. Like I asked you to do this in 10 minutes, right? 5 questions in 10 minutes and you only have 2 minutes each. That's the manipulation, right? And so on. And the other one is without manipulation, we call that control group. Yeah. So, you might have a typical classroom situation. Let people do that in a natural ways. And then you have this manipulation of the condition. And then you want to compare the performance of the two groups there so that you can see the difference or maybe no difference. If there is no difference, then don't recommend these methods or something, right? You make that sort of argument. So that's called manipulation. But you need to check that manipulation. And why do you think it's important? Why do you need to check the manipulation, Hiromi?
So manipulation is necessary for experimental research, right? And
Yes,
then,
absolutely.
so how can you test it? Is my question.
Okay, very good. Anyone else? How can you test it? Vincent, do you know how to test this manipulation?
I'm not quite sure about this one, sorry.
All right. One thing that we can do is we need to predefine the procedures of checking the manipulation. So for example, you need to make sure that for example, the two classes are delivered by the same teacher, right? Because you make sure that that there would not be variations in there. And also if you have different teachers, you have to make sure that they have similar experience, teaching experience or knowledge, so then we can control that. Yeah. So the amount of time we give to learners to to do tasks and so on. So that's kind of a check. Yeah. And therefore, again, we can't really rely too much on it. The situation with this is that you need to check whether it works as it is, as you intend. Yeah. Sometimes it could be something like check your instruments. That's the manipulation part. You need to check your instrument. And if you want to use the technology, say AI, AI agents or whatever things there, generative AI, and you want to make sure that they have good system there, right? Good internet, right? If the internet doesn't work well, then everything slow down, right? And it won't work, like technical issues. And also knowing that participants know how to use, certain prompts or certain, correspondence with the technology there. So you want to make sure that it works. Okay, so this is the system setup that you need to do earlier on. So you need to do a pilot. Okay, do a pilot study. You don't want to just say, wake up, oh, hello, today I'm going to do an experiment. And then you just do it for your research, for your PhD. Then it's not going to work, right? You need to think about it, plan, and understand what could be the situations there, pilot it, and do a bit of check that something works accordingly. Okay, so this is an example of manipulation check. again, we can't rely too much on this because, okay, a very good example of that is you might alert your participants about your study purpose. This is actually a question that people often talk in terms of ethics of research. Yeah, when we do research, we don't want to manipulate people, right? We want to make sure that this research investigates and they need to know the purpose of our research, right? So I think the issue with the experiment is you can tell them, you know, the specific purpose and so on, but you can't be too specific with something because it would then change their behavior, you know. In research we have Hawthorne effect. Have you ever heard of Hawthorne effect? Anyone? Hawthorne effect? Vincent, you knock Victoria, you knock the head. What's Hawthorne effect?
Is that the one about insiders? Or is that the one about being observed?
Yeah, it's about the one that being observed.
Yeah.
So this is back, yeah. This is
it changes their behavior.
Yeah, they change their behavior. This is to do with you know, the factory, the managers, and you know, I can't say precisely what it is, but you know, the place there. But they basically the manager observed that workers are slow, you know, not maybe not doing effectively and too slow. And so therefore they decided to observe the factory. And every time they're there, everyone's working hard. And when they left, then everything's like back to the usual. So that's an example of a Hawthorne effect. When people know they're being observed or being studied, they change their behavior. Okay, we call that a Hawthorne effect. And therefore, if we tell them too much that we are studying them, they would change their behaviors, right? So another good example of that is when you work and then you need to evaluate your own teaching and so on, and then a big boss will come in. I want to observe your teaching, and therefore you really are, I'm a good teacher, you know, right? So that's changed your behavior, and actually maybe in reality it might not be, but also you might be like so nervous that you couldn't deliver. On that day it becomes like a disaster. Like every day you're so good, students love you, you have no problem, but it just happened like someone said, you're so nervous I couldn't do it, right? So like anxieties and so on will change the actual performance. So again, we can't rely on that. So they will know the purpose, and therefore they might sometimes that, you know, we might miss things like we for example in experimental research we need to test our hypothesis, and it's very statistical testing, and we talk about rejecting the null hypothesis, right? We want to reject it and therefore accept the alternative, which is about the cause effect there that we're interested. Okay, the null hypothesis is like there is no effect, no difference, right? But the alternative is there is an effect. And an example of over reliance on this would be something like this. Okay, so imagine that you want to test whether implicit correction can help learners improve their use of English past tense. So English past tense like go, went, gone, eat, ate, eaten, like those stuff. And so one group received implicit recast. So recast is the term when you do it implicit corrections, right? In the speaking. An example of that. Yesterday I go to the library and teacher said, "Oh, you went to the library yesterday?" Okay, so this is an example of recast, right? And so therefore the researchers' hypothesis is that, you know, implicit correction can improve their past tense accuracy. Okay, they want to test that, right? Now at the end, right, the researchers you know, give this manipulation check with the students, like, "Oh, did you notice that the teacher was correcting your grammar?" And then the students might say, "Oh, no, I didn't notice that." "Oh, yes, I do," right? And yes, I did. So in this case, you can see that asking whether learners know or notice that that correction can also make the purpose obvious, that you want to check the implicit correction, you know. So by asking that, right? So therefore, you can't really rely on that, right? Because then it means learners will monitor their grammar more carefully, okay? And also try to answer in a way that they think the researchers expect. So they want to please us. And then we might get the answer that we want. And I think, and then it can not be replicable. You cannot replicate your findings if someone else doing the same study. They cannot do that, right? I mean, they probably can replicate if the same errors maintains, right? And therefore, if learners say, I did not notice, or the feedback, then you might say, oh, maybe you can assume that some manipulation failed, right? Maybe, that's the case there. Question number 4, what might no treatment control group be insufficient in an experimental design? And can you think of an example or the alternative? So no treatment, what does it mean, no treatment?
Means like this one group have like no active like a treatment at all.
Okay, maybe, yeah, okay, that's a good point. Maybe like traditional learning way, think of that, right? And or you don't have the no treatment observation. You only have the experiment. Okay, you only have the experiment. Let's do an experiment, and then you just collect pre-test, post-test, and so on. You don't have any control group. It's not. Why is it not sufficient? Because you can't claim the cause effect fully. Okay, because you don't know about the non-receipt, right? So an example of this would be something like, there could be expectancy effects, there could be attention time, or we call placebo-like inferences. Placebo effects. Have you come across this term, placebo effects? What is a placebo? Anyone? Future educator, what is a placebo? Vincent? Where is Ling Ling? I can't see Ling Ling because
Sorry, I don't know the answer for this one.
Okay. Yes, you can't? All right. Okay. Ling Ling.
I think Victoria might have the answer.
Oh, Victoria, don't.
Yeah, I do. Sorry, I was just
Okay, don't say it, Victoria. Let other people do it. This is an example of what's it called?
Placebo.
Confounding variables. No, I'm just kidding. Victoria, you're the confounder here. Anyway, didn't change my outcome, right? Okay, Ling Ling.
Hi.
No, all right.
Hello. Sorry, can you hear?
Yeah, I can hear you.
Oh no. Little knowledge that I have on research. I think I will pass this question to someone else. I'm so sorry.
Okay, Victoria.
So a placebo is kind of, in a medical trial, the kind of fake tablet that they're going to give to someone as the control. And, when you have the placebo, sometimes you might think you're having the real treatment, so you might start to feel better.
Very good. So, for example, they might like in medical research, right? They might have a specific medication for the experiment, right? The control group will receive just glucose, like sugar or something, or just something that doesn't have anything, or maybe water. Just give them water. And then they feel like, oh, I feel better today because of these drinks, right? That they receive, right? But actually, it's just the water. And that just something like that can change people, and then therefore it's like fake effect, So that is the issue that we really have to have an issue with that, and therefore another alternative way of solving this is to try to have an active control condition that matches the treatment condition on relevant features, except the one that you're really interested. So try to match that. A lot of the things you can match exactly. They can do activities, blah blah blah, but just one thing that's different there. At least you can vary that. There's no such thing as like zero kind of treatment. Anthony.
Yeah, Hey, I just had a quick question about this. I haven't done an experimental design in classrooms, but I always wondered how really no treatment those studies are. That if you have two classrooms, you're saying we're doing the study, one's getting an intervention, one's not. How would you ever account for those teachers or those students talking to each other about what's going on in the classrooms? Like, sure.
That's the issue there. I think that's true. When we do this, I think we need to control that, right? They're not allowed to really communicate.
But how do you control for that?
It's hard to say how do you control for that, but that's the things that you need to basically talk to those people involved. Like say imagine you have two classes, right? And students one class they receive particular way of activities that other class didn't, but sometimes you need to tell them like, please don't share what you do with other class, because once you do that, other class might copy, right? Once they told other class that they're friends, of course you tell them your friends, right? Like,
yeah.
But you happen to be in a different class, and you say, oh, in this class we had this such wonderful activity, and that's what I learned today, and it's like, oh, that seems to be quite good. Let's study more, right? Let's study about that.
Right.
And in the end, when you finish your experiments, and then you're like, oh, there is no difference between the two groups, but it just happened like they also practice, because of that, right? So sometimes you need to have that sort of control. Yeah, I think that's the part of the advice that people normally have. So this is an example of that. They might do other neutral writing tasks, like if you want to do like a class in academic writing or something, you might have a particular way of dealing with that. But another class, in a control class with some kind of treatment, they can do some neutral writing tasks, like general writing. So they can engage in something maybe of equal length or maybe with a similar kind of engagement, but the conditions of the two classes could be quite different. The last question before the break is, can experiment have high internal validity but low external validity? This is another big word here. What is internal validity? Internal validity? Yes, Victoria?
Is that to do with reliability?
Yeah.
Like knowing that your instrument works, that you managed all the variables, that it's a valid design.
Yeah.
And is external validity about generalizability?
Yeah, it's about generalizability. That's spot on. Internal validity is also not just about reliability, it's about the design that you follow through. So you have, for example, pre-test, post-test design, you have control experimental groups or conditions that you want to test, and the period of time that you give into your treatment, so that's the internal part of it. For example, length of treatments can affect the outcome. Yeah. An example of that, sometimes, of course, research can be limited in terms of the amount, the length of the treatments, right? So if you want to, we know that for sure, language learning takes time. It does. You can't learn in matters of weeks. It takes years, right? And of course, the environments and other factors there, and individual differences, special abilities or something, or motivation. But it takes time, right? You can't just say, I'm gonna give this lesson for 5 weeks and I want to see the impact of something, and sometimes you might not observe the impact, even though it is happening. You know what I mean? So that's internal validity in there. But also what we learned so far about language learning and so on, that dynamic system, things are not proportionate, like, they are random, they are not linear all the time. So a lot of the things we do in experiment, we assume some linear relationship, right? That things are, if one thing goes up, the other thing will also follow, or the other end opposite or something. But non-linear, it's very random. It's just very chaos, right? Chaotic. Sometimes, it looks like very messy. They haven't learned anything after one semester. Our students haven't learned anything because their head is like full of stuff. It's not sorted. It's unsorted, and only requires some trigger, and then okay, it becomes good, right? Again, it's complex issue there. So basically, yes, it is. The answer is really yes, because you can have some strong evidence about the manipulation and can lead to this and that, but sometimes it may not be generalizable. Okay, you can't really generalize your finding to other situations, and especially when it's very tightly controlled. Everything's like tightly controlled, but in reality, we know that in a classroom there will be students with high motivation, no motivation. Some students have interest in a particular area, but then not in one area, and then they have to be in there. So, and then therefore the outcomes might not always be the case there. We need to be very careful with that, in terms of looking at cost effect. Now let's have a 5 minutes break. I know it looks like we have a lot to do. Hiromi?
Aek, I think you probably want to see Lin's comment posted at 1:13
about
before
the
the break.
design, right? Design based. So I will talk about this at the end, because we need to go through other design in experiment first.
Okay.
So we actually can differentiate that. All right. Good reminder. Please remind me again. Okay, let's have 5 minutes, tiny 5 minutes, and then we'll come back because they have a lot of. Okay, everyone, let's get going. Some of them will go faster, others will go a bit slow, depending on the speed, and so on. I think will probably give you enough knowledge, or not, or lack of knowledge, that you can do more of the self-study. Okay. So as you can see, what we discussed so far, experimental research is really a situation in which you, the researcher, objectively observe a phenomena or a phenomenon that you really want to learn about the cause effect, right? So then you can strictly control the situation. And basically, when we say control the situation, we want to vary the amount of the variables that you're interested to find out, to see if it makes the cause or can cause or lead to some change, and then make other things constant. So when we say make other things constant, it will be something like the same, two conditions with the same teaching period, teaching time. So both conditions happen at 9 a.m. or both situations happens at 1 p.m., for example. So we fix that. So then that's constant. By the same teacher, so that's constant. The teacher shouldn't be the researcher. Really, that's ideally. You know why? Because the researcher usually will have their own hypothesis, right? you want to show that you're something that you have in my works, right? So if you are the researcher, you are likely, and you believe in something, you probably end up put more effort into doing it, spend so much time and energy and do extra stuff to it, and then outcome is positive. Someone else wanted to replicate or repeat your study, can't find the same findings, right? So that's why we need to have another person to run the experiment, and of course you need to train them so that they know the topic and know the protocols of the research, right? So when we look at experimental research, we really want to study the effects of something through systematic manipulation on one or more variables, right? So it actually could be more than one variables in there. So you can see a diagram here. You have a treatment, you have the individual or the learners, and you want to observe the outcome. Okay. Now I think I would try to answer Ling's questions about design-based research at the end, but you can see that there could be something quite interesting with experiments and action research. Have you ever heard of the action research? Yeah, that's a type of things that practitioner or teachers would do, right, in their classroom. They notice something and then they want to try out something to solve the problems there, right? And then they will observe that, oh, have I solved this problem? And then once it's like, yes, so it works. Yeah. So, but that's somehow share some of the characteristics of experimental research, but then in action research, you don't control it. You don't decide to control things. You just let things to be naturally as possible there. You're not interested in controlling the environment as such, but in experiment you need to control, because otherwise you really have no knowledge of the cause effect for sure. That something can lead to another things there. So in some way, action research could be described as part of design-based research, because you want to solve an issue, and you don't really need to plan things in advance. It just happen to be emergent or emerging out of the situations there. But in experimental research, you need to strictly control and plan everything as you plan. If it doesn't work, you need to stop and redo it from the beginning. Okay, so unlike qualitative research, which can evolve, or you can make some adjustment, in experimental research, if it doesn't work or if you miss something, then you need to start from fresh, which is very, because you can't afford to make errors in your conclusion. So conditions again in experiment need to vary. For example, you can have no treatment. Okay. You can have treatment 1, you can have treatment 2. And then you want to check out the effect of this on different groups of participants, looking at their outcome. Okay, so you want to see if something can change something in there. So in order to understand experimental research, you really need to understand these types of variables in experimental research. So as we know, we have these terms like, independent, dependent. So independent will be something like cause, the conditions or the treatments that you're interested to find out. So we call that independent. Dependent is more like the outcome. So now to explain what it is. So I have it, again, we have these confounding variables that will affect the independence. So other things that are not the independent variables of interest will also interfere, as we talked earlier on. Okay, that would do change. So I have an example of this. Okay, so if you want to examine the effect of vocabulary practice on reading comprehension, so the more you practice vocabulary, the more you will read more effectively or not, right? You want to see the effect of that practice. So here, the independent variable could be something like the amount of vocabulary practice students receive. Okay, so it could be one group receive 10 minutes to practice, another one 20 minutes, and the third one 30 minutes per day. And you want to see that this condition can improve reading. Which one improve reading the most or something? You probably can predict that it might be 30 minutes, but it might not be always the case. You want to have the optimal one, right? The dependent one that you're interested is really on their reading comprehension performance, not their vocabulary performance. You're interested in their reading comprehension performance. Then you can do that, giving them a test, objective test or reading comprehension test or whatever standardized test that you want to give them. And therefore you want to observe the change in there. Okay, so it could be something like you can have pre-test, post-test, give them pre-test before the reading conditions, the vocabulary learning conditions here, and then you give them the post-test, and then you can compare if the performance improve or not. So then the change here could be improve or decline or no improvement. Okay, and that's what we are after in the research. So therefore, you can write something like the amount of vocabulary practice can lead to reading comprehension score, and the change in the reading comprehension score performance that can, so that's what you would be interested to do. So if you want to do an experiment, okay, in language learning or whatever, the first thing you need to, this is a very simple step. You need to select samples of students, a sample from your students or participants there. You need to randomly assign them into groups, experiment or control groups. You can have more than 2. So that random assign. The reason we want to do that is to eliminate a lot of the confounding variables. Okay, if we don't do that, certain groups might contain certain types of characteristics, like maybe high proficiency levels are in there, or people who are really interested to participate will be in a particular group or something. You want to avoid a lot of things like that. So when we do random assignment, we have a system to do it. Like you can assign participants with, say, an ID, and then you run a program, and then you can say like, okay, I want to randomly assign 20 students into 2 groups. Then the computer will program, and then it will run for you, and then it would say like, it just happened like number 5, number 6, number 15, or whatever. It will be in number in group 1, and so on. So it will do that sort of thing for you. You can also consider the so-called stratified random sampling. Stratified meaning that you want to ensure that all specific groups are within both experiment. So for example, you want to make sure that you have the number of highly proficiency learners in both groups, and also equally with some mediocre or moderate learners, and then and then make sure that you spread them, right? So therefore, you need to group highly proficiency first, and then random them into 2 experiments, and then you need to identify the intermediate and then randomly assign them into so then therefore you can contain variety of learners within the 2 conditions, so that you can avoid having biased conclusions at the end. Then you need to plan instructional. In this case, we call that treatment, and then provide the control with some other alternative treatment, maybe typical conditions that they normally have. And then you need to assess the dependent variable, which could be some performance based and so on. You know that this is getting exciting. We have these variations in experiment, right? A lot of the time we do experiment, actually a lot of, like in normal communication, when you say, I'm gonna have an experiment. Do you like cooking? Oh, I don't know. So if you want to say like, oh, I'm gonna experiment in my cooking, right? So you're gonna try something different in your cooking. So you say, I'm gonna experiment this, right? Actually, it's not an experiment. It's more like a hypothesis that you want to have. You want to test your hypothesis, if it is working or if it is more delicious or whatever, or more successful. And that's not experiment. It's more like hypothesis testing. It's only part of the bigger experiment. But in experiment terms, right, in sort of methodological terms, we have these 3 rough categories. We call it pre-experiment, we call it quasi-experiment, and then we call it true experiment. Again, easy, we talk a lot already. True experiment is the design that includes random assignments. Okay, when you can have random assignments, then your experiment will move toward that sort of true experiment, because you can ensure that some threat will be minimized and so on, right? Quasi-experiment, when you can't do random assignments, right? You may have an intact class, like you may have 5 classes, and you can do experiment with them, but you can't randomize the students so that they can mix up, because it doesn't work like that. So again, but you can still have different conditions, different control groups in there. But again, you can't do random assignment, and therefore we often call that quasi-experiment, almost like an experiment, but it's not. So with the quasi-experiment, you can't be definite about the outcomes. You would say something like tentatively or likely the case, addressing the limitation there. Pre-experiment, right? A very good example of that is you don't have pre-test, you don't have control group. You just happen to give a treatment in that classroom, and then you want to observe their outcome in the end, like the final exams or whatever things there. So in some way, it captures some of that sort of idea around action research, like I mentioned before. Like you might want to try out something to help your students so that they can achieve better in the end. Then you can do a bit of action research around the treatment, doing things, something like that. So it's more like give you an idea of how you can do better. And it might give you an idea like, oh, yes, this activity works. Now I'm going to set up a proper experiment, right? So then you can move progression from pre-experiment to quasi-experiment and to true experiment. So what that is, right? So with the true experiment, we have this sort of issue, two things we call randomness. Okay, random. Sounds random. When we can randomize things, we can make sure that some things fall into groups, without bias, right? So imagine something like this. Some parents, when their kid did something wrong, they said, "My kid didn't do it," I love my kids so much that they won't do anything bad, So in that case, there'll be a lot of bias there, right? And then therefore, when they put things like that, you can't make clear conclusion. So randomness will allow us to eliminate a lot of the subjective aspects of there, like in terms of selections and so on, right? So therefore, we have two things here we call random selection versus random assignment. So random selection would be something like there will be a lot of people out there. But you can't have all of them. Okay. An example of that is survey research. When you do survey research, you want to get some sample that represents the population, but you can't have all the population. That's census, right? If you have all population, it's called census. But if you can't have all of them, you do random selection of the people to represent, right? Like who's gonna win election next year or year after, and then you only ask the labor to answer your survey, and the answer is labor, so in that case it's very biased. So therefore you want to make sure that you include all parties, or whatever people eat with that, so then you can do the sort of survey that way. Now, so random selection is to do with the population and the sample of the population, learners group, and so on. Random assignment is really to place learners into conditions, and therefore there's some similarities in there. But random selection is to do with generalizability, external validity. Okay. Did I say external? Yeah, external validity. Like you can generalize your finding. Yeah. But random assignment is to do with internal validity, that you make sure that your study follow the procedure, the conditions that you have. Yeah. Hiromi?
Is it possible to have random assignment without having random selection?
Yes. For experimental research, yes, that is often the case. You might have a strictly conditions around who you can recruit for your research. Yeah. So you might have to do it in your institutes or certain places. You can't have all people to represent, but you only have some group of people therefore it's really important to do random assignments so that we can. What we need to do though is to study the characteristics of the participants. You make sure that you understand their backgrounds and so on, right? So then you can note any kind of limitations you have before you start your experiment. Okay, and then you can talk about the potential limitations of your research in that way. Good point. So basically, this is the explanation I will have to skip, and I'm gonna send you this PowerPoint, right? I already explained this. So random selection is to do with how you would choose people from a larger population, but in an experiment, sometimes you can't do that, but other times you can. If you have more money, you probably can. If you sponsor by big industrial partners or whatever, you probably can. But otherwise, if you do for a PhD or your small project, that way you probably can't. Random selection is really when you want to assign people into experiment and control. So in other words, you need to establish this because you want to establish the internal validity of your research. If you want to publish in in referee journals, high impact journals, you need to establish this, because if you don't, then they might just reject your articles because there is a problem in your design there. Unless you say outright from the beginning that your research is quasi experiment, right? Or say pre-experiment or something. Okay. Now, just want to go through this quickly. This is based on my book, 2014. Just to show you what a pre-experimental design look like. So you can see here, just give students a treatment and then you observe the outcome. Okay, so we call that pre-experiment. So if you do anything like this, we call that pre-experiment, because it's not really experiment as such. Of course, you have a treatment, but you don't control anything. You haven't controlled things. You don't have groups to prepare to work on the conditions and consider confounding variables, consider conditions that you want to see if it matters and so on. But often we call pre because it gives us an idea. It's more like a pilot in some way, right? Before you apply for a big research grant, you do a bit of a pilot. You see, oh, this treatment, how it works here. Like, for example, I might have AI tutors, to give to students and see how it helps them and how it helps students. And then I was, oh, that actually works. I want to do a proper experiment after. So then you can work out on that after. It gives you an idea in some way. You can have this so-called one group pre-test post-test design. So again, only one group. Yeah, one group, no control group. So you have pre-test, give them the sort of treatment or learning conditions, and then you observe in the end if they improve. So in this case, you compare pre-test and post-test performance. If it gains, if it decreases or increases, right? So in this case, it's still called pre-experiment because you don't control the condition. No random assignment, no control conditions in there. So you can't really see what about those who didn't receive the treatment. What would they look like in terms of their pre-test and post-test performance? We don't know that. Okay, so that's why it's still called pre-experiment. You can also have this post-test only. Now you have two groups now. In this example, it looks more like quasi-experiment because you don't have random assignment. As long as you have random assignment, it will lead to the so-called true experiment. So in this case, at least it's better than no one group. At least it's better. Okay, it's getting better. I would say start from something. Or another one that's quite interesting in experiment, we call it single case design. Don't get confused with case study. Okay. In some way, it's a case study of quantitative research, I guess. Okay, it's like a case study, really. It's a single case design. In this case, it's like people with, say, unique issues or characteristics, and then you want to see if some treatment works. Okay, an example of that is people with dyslexia. Dyslexia, when you sort of mix up the words and then you can't read, you can't write because you mix up words and orders and so on. The way you see is quite different from what other people could. So in that case, it's a unique case. You can't have a group, right? Experiment is usually deal with groups because you want to generalize, right? But single case is usually with a unique learner or individual. So in order to do that, you need to establish the so-called baseline. So at the beginning, baseline. What is it like? Observe so many times. What is this person like in their reading? Okay. A lot of issues that you observe. Oh, okay, this is the situation. And then you give the treatment and observe multiple times. And then after that, you want to, and you might gain like, oh, they improve so much, right? And after that, you need to leave them. And then you want to see like now they have no treatment, has the treatment makes an impact later. So you have later observation to see if it go back to the baseline, if it go back to A. And if it doesn't, it means that the treatment actually works. Okay, so that's more like a case study of quantitative experimental research. Another one which is getting more sophisticated is this. Okay, it's called more like through experiment. Really, you randomly assign people into groups, into treatment, and then after that you give them the post-test, but you add the after effect. So you have delay post-test. Okay, so what you can do with this, right? So imagine you have in instruments. What you can do, you can compare. Oh, not quite. You don't have pre-test here. It's still more like quasi experiment. Actually, it doesn't have pre-test, so you don't know what people are like at the beginning. You only have post-test and delay post-test. Of course, it's more robust in that way, but it's not quite fully functioning in that way. It's called post-test only group. Then you can have the so-called repeated measure design. Again, in this one, non-random. So you can see here, you can have group 1, group B, A, B, C, and then you can have randomly there. So group 1 receives, say, treatment 1, A, and then treatment B, treatment C. So you do that sort of thing. So what looks like everyone's exposed to all conditions, and then you want to see which one they perform the best, right? So if it happens like everyone in that received treatment B in across the 3 groups here also perform much better, then you can make some kind of conclusions about the effect of something which might be better, right? But the problem with this is it could be an order problem. Like maybe you're exposed to something and you learn about something, then it improves the learning of another thing, another conditions there. So this will be the effect that we can't control. We can't be sure. Okay. This one is now more like through experiment, very traditional way of thinking. So we will randomly assign participants into groups. You have pre-test, right? And then you do the treatment, and then you do post-test. Okay. If you want to make it more complicated, you add delay post-test at the end as well. Okay, you can work out on that. With this one, then you know whatever statistical finding about the group difference, it's more robust than without random assignment. We'll have a no more break. Okay. Now I'm gonna skip this. Maybe it's more like your homework, really, because of the time limitation that we have. So I have these activities for you. That I sent to you. Basically, it's about designing and thinking about how you would design based on the diagrams that I presented, for example. So, for example, what do you do? How does providing explicit corrective feedback on oral errors impact speaking accuracy in intermediate level ESL learner? So you want to work on this. Now, just do it together before we move on to other part, right? So what is the independent variable in this research question? What is the independent variable here? How does explicit corrective feedback on this independent variable is?
Feedback.
Okay, feedback, but explicit corrective feedback is the independent variable. What about the dependent?
The speaking accuracy?
Yeah, okay. So that's it. So how would you design this?
You want to select students in the intermediate level proficiency first, and try to do the random sort of grouping. So you can have like 2 different groups with the same amount of students, and one with the corrective feedback, the other one without the corrective feedback.
Okay. And you can see here one explicit, right? The interest is on the explicit corrective feedback. So therefore, the other conditions might be implicit, like recast, or then without any feedback, just whatever things there as the usual traditional way. The focus is not so much on that, but in the end, they would just have to measure speaking ability, right? Or in terms of accuracy, like grammatical. I would say when they say speaking accuracy, they are talking about grammatical accuracy more or less than anything else, than pragmatic accuracy. I think pragmatic is a different sort of measures of speaking. It's probably not of interest here, but it might play a role in some way as mediator or something. Then in this one, how you would control assignment and so on, right? So this is sort of the task that you really need to think about. I already have some of the answers or idea, but I will skip that, okay, for you. And I will send, of course, your PowerPoint, but do try to work on that, because that's how you would work on your research if you want to go out that way.
Hey, could I ask a quick question just about that last first example? I know we talked about just really quickly doing a pre-test, intervention, and post-test. Are there situations where a delayed post-test wouldn't be appropriate in that kind of experiment?
If you can, it would be appropriate.
Yeah, I was saying, where would it not be appropriate to do a delayed post-test?
When you don't have enough time.
Okay.
Or run out of time. And the situation with delay post-test is sometimes participants already finish the experiment with us, right? Mm-hmm. And then they move on to do other things. And sometimes it's hard to ask them to come back and do it. Mm-hmm. That's often is a situation. Okay. So then you lose your participant that way. So therefore you need to make sure that you have you can hold on to those groups for a period of time before they could do the delayed post test. Okay. Okay. So you need to factor that in your design if you want to do it. Hiromi?
If people practice after the a sort of a post test.
Yeah.
Right. It might sort of manipulate the effect of the experiment if you have got the sort of a another post test. Would it happen? Do you understand what I mean?
I'm trying to figure out.
Yeah.
So you mean should be different tests, right?
Yeah. When you have got two, say, post tests, right?
Mm-hmm.
And then the first one, you might not have time to, practice, right? So the test itself is quite accurately measuring the effect. Oh. So after 1 month, you do the same test or another test, but some participants may be practicing.
Yeah. Okay. Yeah. So then it could be maybe to do with more of the impact of the treatments that continues after they finish the experiment, right? So that's about the long-term impact of the treatments that somehow trigger them to do that more of that, so that they can increase and do this and that. So therefore, if they show that they do better even than the post test, then it means it gives you some kind of evidence about potentials of the fact that the treatments can last longer. Does it make sense? And likewise, after the experiment, they might not practice at all, and therefore in the post test they couldn't perform well. So it's basically got the kind of regression, back to their earlier ability there. Yes, you know me? Good?
Yeah, thank you.
Okay, and I just want to note that in an experiment, usually the things that people do is they might use the same test. Yeah, so pre-test, post-test, look, there could be a situation they use exactly the same pre-test and post-test, right? But we know that there could be a problem with that, because there could be a memory problem, because that you can never do the same test twice. Each time you do it, it's a different test, right? But you can have a memory from you completing the first one, and like, oh, in the first one I know that I did well, and I didn't do well in that first one. I thought about it and now I know how to do it. So there could be a memory problem. So there will always be gain in something, right? So then the gain should not be in some way random gain might be, or in that case situation might be okay, but it shouldn't be because of the memory, that improve the performance, right? And therefore we recommend that we develop test specifications so we can have the so-called parallel test form. Okay, parallel test. Especially if you're interested in the performance. It's like, IELTS test or TOEFL test, they have many forms there, but they measure similar constructs. They have different activities and different questions there, but in the end, they can standardize and come up with a sort of grades or ability levels there. So that's a sort of parallel form we call. Okay. So in that situation, yes, I think we recommend that we use parallel form rather than exactly the same test. But if you're interested in, say, attitudes, motivation, and so on, you can use the same questionnaire, because then it's a measure of traits, right? Or characteristics, or certain cognitions or beliefs or attitudes. Then you can see the change there. It's fine to use the same instruments. But for assessing language performance or ability, it's better to use a different test, but measure the same thing. Okay. Now move on to quickly with this validity thing, and today I've got something that I want to share with you as well about the current special issue in research methods in Applied Linguistics journal, and they have the online experimentation things, which is actually quite interesting. Usually when we talk about experiment, we want to have more like face-to-face sort of experiment, right? We do have a classroom control, we have a physical control in the experiment. But nowadays, it looks like there's some gains of acceptance in doing online experiment. So imagine like this, you are at home or at work somewhere, and then do the experiment with me. There will be a lack of certain controls out there that will influence, right, the environment or whatever things that the attitude, motivation, or whatever factors out there. And sometimes like access to AI, blah blah blah, and different resources can be influenced. So that's online experiment. So I think that's a special issue there. I think we need to introduce to. But when we talk about experiment, we need to address the so-called validity and reliability. Really, it's about appropriateness of the interpretation of your study, and that's the valid. It's to do with how you can learn about the cause effect in relation to the theories that you're interested, the knowledge that you want to develop in there. Reliability is to do with the consistency, really, of your instruments or of your study. So reliability is for the study means that you establish procedures that people can follow. If they can redo like what you have done, they can follow that in a consistent manner. So in that case, you have the reliability of the study. But in terms of the instruments, it means your instrument can measure some constructs or some ability consistently over time. So I think that's for the instrument. But you need to have good instrument reliability before you can claim your internal validity in that way. So here will be so many things that you can talk about, right? So we talk about content validity, about representativeness of your instruments in your instruments. Best validity is to do with the fact that your instrument looks like it assesses the target constructs. Okay. So for example, if you want to measure speaking, you make sure that your participant actually speak, right? Have conversations and this and that. So that's speaking, but you can't give them multiple choice reading questions. And a lot of people say that, oh, I'm going to test their speaking, but I'm going to give them multiple choice questions. But in that case, it doesn't have face validity, right? So you need to make sure that you meet that expectation. Construct validity is to do with your theory, really. what do you know? How do you define the construct in your research? Criterion related validity is to do with how your instruments can be correlated with other measures, especially for established one. We already explained about the internal validity already, so that's to do with your own study design. Okay, so we call that internal. External is, like Victoria said, generalizability, that you can generalize your finding. There are also threats. I think one thing that we mentioned earlier on is Hawthorne effect. People change behavior because they know they are part of the experiment. They know what we are after, right? So threats really important for us to consider in experiment. We have, again, internal and external validity of the threat. So in terms of the internal, we want to ask the questions like, does or did the experiment treatment actually cause the change? That's the basic questions that we ask. So there could be the so-called history as a threat. So again, it's not about history as such. It's something that an events that may happen at the time during your experiment. Okay, that might influence the outcome, like things like news events or wars or earthquakes or floods or whatever. So things like that can affect the outcome. So I think that's called that. Maturation. If you want to research young children, because their brains develop, right? It's a natural progression of human development. So they are become, as you know, people become smarter as they grow older. Hopefully this is true. As you get older, you're smarter. Okay, so that's the hypothesis. But children get smarter as they grow up. I think. So therefore, it's something that change over time. It's naturally occur. Blah blah blah. It can have something like that. But it can also be something to do with the psychological process as well. So things like what's it called, hungrier, or when you feel like tired. When you're tired, it can affect the outcome. The testing effect is to do with your instruments as well, like the kind of pre-test, post-testing. Instrumentation is your actual instruments, like how you would use to observe the dependent variables in there. Statistical regression is when you move back to the earlier stage. Okay, you sort of moving toward the average, in other words. It's kind of natural that way. So if you don't perform well at the beginning, you are likely to go to the middle after the treatment. And similarly, when you perform really well earlier on, you might tend to also go back to the middle. So we call that statistical regression as a threat there. Selection bias is another one we mentioned about this. That's why we need to do random things like that. We also have attrition. People leave the experiment, right? Or what for? Because they can withdraw, right? Or there could be other reasons in there. External really is to do with how do you generalize your finding. There could be some reactive effect of the testing in some way. Some pre-tests may be sensitive to participants. May sensitize participants into the treatment, and therefore the result can only be applied to to only those who have done the pre-test. Interaction of selection and treatment. So it could be something like some unique features in there. For example, volunteers or students at a single university. This definitely is a factor in there. And I think Hiromi mentioned, like, do we need random selection? And in experiment we don't, but it will play an important role in the conclusion. Okay, we'll skip this. I think you can read this, and we don't have this activity. We'll skip that. And I have an example for you. And then I will move on to this one. This one, before we go, is I think it's quite important for us to look into the new trends and so on. When we look at this, the journal is Research Methods in Applied Linguistics. it's now getting momentum. It started a few years ago. Now it's got a lot of good publications and series, and there is one special issue on online experimentation, edited by John Rogers and Bronson Hui. It's actually quite interesting to read. I have an issue with this, a little bit with this, because it's supposed to be a special issue, but when you look up the journal itself, it's not sorted. It's like publication first kind of thing, like they accepted, they put it in there, so it's not in one single place at the moment, so you need to do a bit of a search. But definitely you can get some of the, I've got a few that I could download from this. They all open access. I can send this to you as well after this. Okay. Actually interesting. But what we learn about this is that you can see experimental research started a lot during the COVID, because people can't move to places, right? Physical and so on. So they started during that sort of COVID, more probably predominantly during that time. So they did a bit of experiment during like online experiments and so on. And even after COVID now, it looks like they learn a lot about problems or threats for that, and then people try to address the issue. So things like technology, participant recruitment, their performance, and so on. So assessing the accuracy, reaction time, learning trajectory, webcam eye tracking that can be done that way, or browser movement. But things like this, being carried on, and we learn a lot from this, and it looks like they use the issues to improve the research on this, right? So here will be the 10 recommendations when people decided to do an online experiment. So you really have to make sure that they brainstorm carefully about the certain specific threats to their data quality. They want to pilot a lot. Okay, pilot a lot, then so that they can learn something. When I did my research on integrated writing, online writing, I learned through the pilot, because at the time when I did it, no AI. Luckily, I'm so glad. I'm very glad. When I did that data collection, no AI. Okay, no generative AI. So I have the online, so they have to type, in the answers and so on, right? Luckily I didn't have that. But what I learned was also like some students supposed to turn off something, but they didn't. And then like, oh no, you can't use that. So I learned from it. So an example of that is the pilot. Then you realize the issues and you try to prevent. You need to make a video to make sure that they understand this and that, right? So you work on this clear instruction, multiple attention to different things, check comprehension, that they understand what they're supposed to do. Okay. And you can think about how to report attrition or exclusions, issues of technology in terms of the validity threats that I mentioned before this. How do you do debriefing, after the experiment and so on. So these are the key things that you probably can work out. But what we learned so far, if you read some of the articles, they have a lot of discussions around this, around the online experimentation, that could become more and more rigorous and useful for the field, but we really need to manage the threats to the validity, and we need to make sure that it is transparent enough for people to understand the topic, and that they can have some knowledge around that. All right, so I think we have to stop. It's good. I will come back to this, but I've got something that I did a bit of work around this thing with Ling. As she said, she's gonna watch the video, so I make sure I include this here. So at least it's useful. So now there are a lot of differences between experimental research and design-based research. So think of design-based like action research as part of that design-based. So experimental research is really you want to examine cause effect, right? Causal relationships in some way. But design-based, on the other hand, you want to improve the practice. You want to improve something. You can build some theories around it, and things can be iterative, meaning that it could be adjusted and change accordingly. But the experiment often is fixed. Okay. Where is it? Yeah. So in terms of the design on the last line there, experiment, you need to often fix the design at the beginning. You need to follow that. So you imagine you apply for a research grant to do an experiment or something. You need to make sure that you tell them these are the steps that you would follow. You can't skip one. Or if you have a false start, you start a new one. All right. So then it's often fixed, because otherwise you can't claim validity and so on. But design based tend to be more flexible. You can make changes and this and that. So it could be qualitative in nature, adjusting and so on. Could be in a natural environment, whereas in experiment it tend to be in a strictly control conditions there. Okay, so we have a different interest in the research question. So because experiment is a cause effect, so you want to see if one cause lead to better outcomes or something, whereas in the design base, you really want to make sure that you can redesign or design, and then you can adjust to support some kind of learning in there. So before we go, any questions? Right on time. I know I skip a lot. You didn't do a lot of activities. We need longer, but any questions? No questions? That sounds good. All right. Thank you, everyone. I will send you the PowerPoint.